Hello everyone. Today we will look at how we can detect and resolve collisions. So you can see that we basically do not allow our agents to overlap anymore. So let's see how we can do this. We are going to work off the code for tutorial number 5. So copy paste that and rename it tutorial 6. If you do not have the code, of course, you can download it from the page that I linked to in the video description. So let's remind ourselves what this program did. So basically, we have a bunch of agents and we can select them and send them to different places. The only problem here, however, is that we can also overlap them. So this is undesirable, and let's try to fix it now. So let me just drag the code in. This is the code from tutorial number 5. We learned how to create classes. In the init method, we do some initializations of our agents. In the update method, we update every agent's position according to the target of that particular agent. In MouseUp, we do all the user interaction stuff, so basically giving a target to every single agent. And finally here, in the draw method, we draw all the agents. So now all of our work today will be actually in the update method, because this is exactly where we update all of our variables. In particular, this is where we update the positions of every single agent. So right after these positions are updated, what we would like to do right after that is we would like to first detect any possible overlaps and then resolve every single overlap by unoverlapping agents. Detecting if two agents overlap is going to be the easy part here. That's because we know where every single agent is, and we also know how big these agents are. They are 20 pixels in radius. Therefore, if we can ever find two agents who are less than 40 pixels apart from each other, then we know that they must be overlapping. So here we're going to iterate over every single agent for A in self.agents, and we're going to check its distance to every single other agent in a simulation. So for A2 in self.agents, we will want to solve for the distance between two agents. One of the things here is that you need to keep in mind is that we really want to check distances only to every single other agent than A. But here when you're iterating over the list, self.agents, you're iterating over the same lists. So at some point A2 is going to equal to A, and you're going to be checking distance from one agent to itself, and we want to exclude that possibility. So if A is A2, then we would like to continue. Continue is a keyword in Python that simply skips to the next iteration of the closest loop. In other words, we will ignore everything that follows and we will go to the next A2 in the list. When we get to this part of the loop, we basically found two agents, A and A2, and they are distinct. Now we would like to check their distance. So we will take the position of the first one, and remember that this is a vec2d object. And these vec2d objects have a very useful method called getDistance. This is a method that takes another vector and it basically returns the distance between the two vectors. The other vector we are interested in is A2's position. So in other words, this will return the distance between A and A2. And if this distance is less than 40, then we know we're in trouble because these two agents must be overlapping. So here we are going to resolve the collision. The way we fix this overlap is actually going to be pretty simple. When these agents overlap by some amount, we are simply going to push A2 away from A by half of this distance, half of this overlap, and we are going to push A away from A2 by the other half. So basically, we will move them apart from each other by a total of a distance of whatever the overlap is, and they will be touching at exactly only a point in there. So let's write the code to do this. First, as you saw in the picture, the overlap between the two agents is simply 40 minus the current distance between the agents. That's how much they are overlapping. So you can see that if they are touching at exactly a point and the distance between them is 40, then the overlap is 0, as expected. Now let us solve for the vector that points from A to A2. In other words, we'll take A2's position and we'll subtract it from A's position. This vector dir is then a vector that points along the direction from A to A2, and its length is currently the distance between the two. So now we would like to move A2 along this direction, but only by overlap divided by 2. The way we can do this is we will set dir's length to overlap divided by 2, but the vector is going to retain its direction. So now we can simply do A2.pos is whatever it was before plus dir. So we're basically pushing along that direction only by overlap divided by 2. And now we would like to move A, by the exact same amount in the exactly opposite direction. In other words, A's position is whatever it's now, and plus sort of exactly opposite, which is negative there. So I'll just do negative there. And that's it. So this should work. Let's launch it and see. So there you go. You can see that the agents, oh, it's tough for me to actually create. There we go. So we don't allow them to basically overlap. Anytime we detect two agents are overlapping, we push them apart and exactly make up for that overlap. So there you go. It doesn't take too much to implement collision detection code. What is this, 10 lines of code or something? Now for your challenge, I would suggest you try to implement the following. See how this agent has a lot of trouble getting through these other guys? It's because all the agents have sort of the same priority, and they keep pushing back on him, so it's really hard for him to get through. So for your challenge, try to implement what I call the Rambo mode. So basically, the selected agents should have no trouble getting anywhere. They should not be slowed down by anyone. They should just be able to go through and anywhere they want. So see if you can implement that. Good, so that's it for now. Again, as always, you can download all the code from the link in the video description. Next time we are going to start doing some graphics or maybe some physics. I haven't decided yet. In any case, I hope you enjoyed this tutorial. Thank you for watching, and bye-bye.